Polymorphism is one of the four concepts of OOP, which they are encapsulation, inheritance, abstraction, and now polymorphism. You can check out my C++ tutorial playlist where I have a video for each one of these concepts. But today we will learn about polymorphism. So polymorphism in OOP is where you can treat objects as if they were objects of a base class. Also, it enables a function or operator to work in a different way. So what we'll talk about in this video is about compile-time polymorphism using function overloading and operator overloading, and runtime polymorphism using function overriding. And in the next video, we'll talk about polymorphic behavior and downcasting. So let's start with function overriding. So what is function overriding? Well, basically, function overriding means that you are overriding the implementation of a function that belongs to a base class. So basically in front of you we have a class called operator, and we have a class called operating system, and we have a class called iOS which inherits from the operating system class. So basically this is the derived class and this is the base class. This base class has a function called void getInfo function. And if I want to apply the function overriding concept, I want to override this function inside my derived class. So I want to override this base class function inside my derived class. So what I need to do here is I need to set this function as virtual. So when I set this function as virtual, this means that the base class here, the derived class here, is able to override this base class function. So let's go ahead and try it out. To override this base class function, I will write virtual void getInfo. So I'll write the function name, and I could follow it by a override keyword, which signifies that this function right now is being overridden inside the derived class. And I could give it a different implementation. So what overriding means? It means you want to give a function a different implementation. So I could say something like cout I am the iPhone OS. Something like this. So what I did here is I overrided the getInfo function inside my derived class. And let's go ahead down here inside the main and create a iOS object. So I'll create an iPhone object, and what I'm going to do is I'm going to say iPhone.getInfo, and let's see what we will get. As you can see, I am the iPhone OS. So basically I got this version of the getInfo function. But now you're going to ask me what happens if we take off the implementation of the getInfo function inside the derived class. What will this give us? Well, let's go ahead and see. So basically it gave us the implementation of the base class function. Well, why is that? Well, basically what the compiler will do is that when it's going to execute this statement, what it will do is that it will look inside the derived class and search if this derived class has a implementation or a version for the getInfo function. If it has, well, it will execute this version. Otherwise, if it doesn't have it, what it will do is that it will go to the base class and execute this version. Okay, now what I want to show you right now is that I'm going to create an operating system pointer. So I'm going to create a pointer of type operating system, and I'm going to call it PTR. On this line, I'm going to assign it as null PTR. But after this, what I'm going to do is I'm going to say PTR equal to address of iPhone. And as you can see, I am assigning the address of a derived class to a base class pointer. Now, let me go ahead first of all and take off this comment right here. And what I'm going to do is I'm going to use this pointer to call a getInfo function. So let's see which getInfo function will be called. As you can see, I am the iPhone OS was called. So the derived class version was called. And now you're going to ask me what's happening over here. So basically what's happening over here is called dynamic polymorphism. And this is a form of polymorphism where a base class pointer points to a derived class object. Well, basically it is polymorphism because you are treating a derived class object as if it was an object of its base class. We are treating this iPhone as if it was an object of the operating system. And this is polymorphism. Now the main question still is, why did this version got executed? Well, basically because this function is virtual, then this this pointer right here of type operating system was able to access a virtual function from the derived class. Now let me show you. If I had a void function like this, watch what will happen here. If I use the pointer like this, I can only access the getInfo function. I cannot access this void function right here. Why? Because it is not virtual. So when you use a base class pointer that points to a derived class object, you can only access the virtual functions inside the derived class, and you cannot access the non-virtual functions. Okay, so keep this in mind. Now this is one of the topics that I will discuss in the next video about polymorphic behavior and downcasting, so make sure to stay tuned for the next one. Now let's go ahead and learn about function overloading, which is a type of polymorphism, which is also called compile time polymorphism. Now why is function overloading a form of polymorphism? Well, because basically you are giving a function extra work to do. Let's go ahead and see it. So basically inside this public section, what I'm going to do is I'm going to create a add function that simply adds two numbers. So in num1 and num2, I'm going to return num1 plus num2 like this. And let me say return like this. Okay, so I'm adding two integers. Nothing wrong with this. This is a normal function inside a class. Now how about I go ahead and overload this function? What does overloading mean? You are overloading the function, meaning you are giving it extra work to do. In the concept of function overloading, if you want to overload a function, either you give it different return type or different number of parameters. So basically what I want to do here is I want to allow the add function to add three numbers. So what I'm going to say is I'm going to say int add, I'm going to redeclare it, but this time with different parameters. I'm going to say num1 and num2 like this, but this time with num3. So I'm allowing this function add to add three numbers. So it has three versions, or excuse me, two versions of the add function. So I'm going to add num1, num2, and num3. Now if I go down inside the main and create a math object, I'm going to call it math. I'm going to say cout math.add like this. Now if I go ahead and give it 1 and 2, that means I want to add 1 plus 2. So we basically need to get 3. Now which version of the add function the compiler will use? Well, basically this is the version of the add function the compiler should choose. So during compile time or at compile time, when the compiler reads this statement, what it should do is that it should choose whether this version or this version it should choose, or it should take, excuse me. So what will happen is that the compiler will look at the number of parameters, and based on that it will assess whether this one or this one is suitable for what we give it. Because this one has two parameters, so basically this function will work. Also, I could go ahead and change the return type to double, and I could make this add function add two doubles. So I could say num1 and double num2. Now if I go ahead and say return num1 and num2, same thing. So return num1 plus num2. I am adding two doubles. Now what happens here if I say 1.2 plus 2.3? Now the compiler looks at which one of these functions accept two doubles. Because only this function accepts two doubles, so it will choose this implementation and it will run the code with this function. So let's go ahead and see it. I will go ahead, compile, and launch my code. As you can see, 3.5. So basically this function was called in order to solve this situation. So function overloading is a form of polymorphism, but also we have operator overloading. Same as function overloading, you are basically overloading a operator, so you're giving it extra work to do, or work that it doesn't normally do. So what we're going to do right now is that I'm going to create a grade object. I'm going to call it grade 1, and I'm going to assign the value of 98. So let's say 98 over 100. And on the next grade that you got, maybe you got a 89 out of 100, like this. Now we have two grade objects. What I want to do here is I want to see out grade 1 plus grade 2. So I want to add my two grade objects. Now this doesn't work right here. Why? Because the plus operator right now doesn't know how to add two grade objects. If you say cout 1 plus 1, this will work because the plus operator knows how to add two integers. What we need to do is we need to teach this plus operator how to add two grade objects. Let's see how. So because we want to add our grade objects, I want to add 98 plus 89. When I say this statement, I want this calculation to be made. So basically I'm going to go inside my class and I'm going to create a function. This function will have a return type of integer because I'm adding two integers. And this function is called operator plus. This is the function that will overload the plus operator. Now I'm going to pass to this operator function, I'm going to pass a grade object by reference. I'm going to call it other. What I'm going to say here is I'm going to say return this grade plus other dot get grade, like this. Now let me show you if it will work or not, and let's go ahead and explain it after it. So I'm going to say like this, compile and launch. As you can see, it works properly. Now what's going on here? So basically grade 1 right here is the first operand, and so if this is the first operand, so it is the one who is initiating or calling this function. Grade 2 right here is the second operand. So it is the one that is being passed as the argument or input for this parameter. So that's why I passed this parameter, which represents the second operand. In our case, it will be grade 2. So because grade 1 right here is the one who's initiating the function, that means it represents the this pointer. So the this pointer right here points to the grade 1 object. So that's why I use it right here, and I added it with the grade 2, which will be the second operand. And so there it is. Now you could do the same thing for the minus operator. So I could say operator minus, also pass the second operand, and I'm going to say return this grade like this, and I'm going to say minus other dot grade like this. And so this basically works. If I go to say -1 right here, as you can see there is no error, so this basically works. Now you could do the same thing for comparison operators. Let's go ahead and test for the equality operator. So if I go ahead and decide, for example, to say bool expression like this, and I'm going to say equal to grade 1 equal to grade 2. This still doesn't work because we need to overload the equality operator. What we need to do here is I'm going to say bool operator like this equal and pass a second operand, which should be our grade 2 because it is passed as second operand. So I'm going to say other like this. What I'm going to say here is I'm going to say return this grade, so this grade equal to other dot get grade like this. And let's go ahead and see there's no more error. Let's go down here and go ahead and say cout bool alpha like this, and I'm going to assign, or excuse me, print my expression. Let's go ahead and see what we will get. So I will compile and launch. As you can see, we got false definitely, but if let's say on the second grid you also got 98, that means it should be true. As you can see, it is true. Also keep in mind you can overload more than just these operators. There's still the multiplication, the division, the modulus sign. There's also the difference operator, less than, greater than, less than, equal, and so on. Alright, thank you for watching today's video. Make sure to subscribe to stay up to date for the next C++ tutorial video. So I hope to see you in the next one.